Today we will continue evaluating trig functions and um, be able to evaluate a trig function of an obtuse angle, an angle anywhere on the circle. Alright, so where are the angles located? We can talk about 0 degrees or 0 radians and pi radians. If we look at, we could divide it into 4 angles on top, and that would make that pi over 4, 2 pi over 4, 3 pi over 4. This is pi over 2, 3 pi over 2. And you can count your way around. We also have, if we divide the top half into 6 parts, 0, pi, so this will be 1/6 of pi, 2/6 of pi, 3/6, 4/6, and 5/6, and you can go around. Okay, so a new concept for today, new vocabulary is if we rotate to that angle, and that is theta, then this is called the reference angle. So that little mark means the reference angle, and the reference angle will always be positive, even if we say theta is there. If theta is negative 70 degrees, then the reference angle is 70 degrees. And here we have an angle all the way over there, and if that's theta, then this is the reference angle, and if theta is 250 degrees, then the reference angle is 70 degrees, because we would go 180, and then what is that angle? It's 70 more than 180. And a little more vocabulary, and that is standard position of an angle. So if we have these axes and we start at 0 and rotate this far, this is called the terminal side of the angle, and this angle is in standard position. And if we look at an angle like this, if we start here and we rotate there, this is not standard position because it didn't start at 0. Standard position starts at 0, just like we've been doing in the previous lessons. Alright. So if you don't know where 120 degrees is, you could determine whether it's a multiple of 45 or 30. It's a multiple of 30, so we could look at all the 30s and just count until we get to 120. 30, 60, 90, 120. So we're rotating there. So there's the location of the angle, 120 degrees, and then the reference angle is going to be what's left over there. So in this case, if we went all the way over, it would be 180. So the reference angle would be 180 minus 120, and that's 60. If you draw this picture, you can also just count. 30 plus 30 is 60. Here we're counting by, let's not count by thirds, let's count by sixths. So that would be 10 pi over 6. Then we will look at these again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If we divide it up into sixths, we count 10 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That means we've rotated all the way over there. 5 pi over 3. We need to know what is this. So we would say that if you draw the picture, you can count it as pi over 6 plus pi over 6 is pi over 3. Or you can just say, instead of going all the way to 2 pi, we're going to subtract 5 pi over 3. So then we'll get a common denominator times 3 over 3, 6 pi over 3, minus 5 pi over 3 is pi over 3. And you see that in the picture also, that's pi over 3 there. Pause the video and try the next two. .370 is not a multiple of 45 or 30, so we'll just have to think of where that would be. If we go this far, that's 360, so we're going to go beyond 360, and that'll be to 370. Then we just find out what this angle is for the reference angle, and in this case, we want to find that angle. We've gone beyond 360, so we could just say 370 minus 360. So instead of thinking of a rule determining what you subtract, I think it's best just to look at the picture and see how what you should subtract. This is a multiple of pi over 4, so we can draw these. And we're going to go negative 3 of them, 1, 2, 3. Then we just have to find out what's left here. And from the picture we can see it's pi over 4. Or we can go, it's negative pi minus negative 3 pi over 4. That's not going to work. It's going to give us a negative. So why don't we do pi minus 3 pi over 4, and then we'll get pi over 4. We just know that the reference angle will be positive. All right. Let's review the trig ratios: sine, cosine, tangent, and we know that these are opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent, adjacent over opposite, hypotenuse over adjacent, hypotenuse over opposite. These work if you have a triangle, but if the angle is on an axis, then you just have to know these in terms of x, y, and r. So this is going to be y over r, x over r, y over x, x over y, r over x, r over y. And that's in reference to theta, y, x, and r, and that's the same as adjacent, opposite, and hypotenuse. Hypotenuse opposite, adjacent. And when we look at it this way, we can have positive or negative x and y, but the r will be positive for now. And this is on the terminal side of an angle in standard position. So we could look at let's graph the point over 3 up 0, and it doesn't form a triangle, so it might be confusing to use SOHCAHTOA, but we do know that the x is 3, the y is 0, and the radius is 3. Now we have x, y, and r, so we can just substitute that in for sine is y over r, y over r, cosine is x over r, tangent is y over x, y over x, and then we can just do the reciprocals. Reciprocal and reciprocal. We do have undefined values. Alright, same thing here. 1, 1, and we want the x value, the y value, x, y, and the radius. If we do the Pythagorean theorem, we know it's a radical 2, and we also memorized that from the special triangle for a 45-45. That's a 1, 1 radical 2. So now we have y over r, x over r, y over x, x over y, r over x, r over y. And then we just look at the x, y, and r. The y value is 1, the radius is radical 2. X value is 1, radius is radical 2. Y is 1, x is 1, x is 1, y is 1. We can do the reciprocal of that and the reciprocal of that. Here we'll multiply numerator and denominator by radical 2 and we get that. Same question. And try those. Pause the video. So we have an angle at 0, negative 1, 0, negative 1, and the radius is 1. We'll always have a positive radius for now. X, Y, and that'll be, for this whole chapter, and the next chapter the radius will be positive. Sine and we need y over r, cosine will be x over r, tangent y over x, and then we can do the reciprocals. Cotangent reciprocal of that would be 0 over -1. Secant reciprocal of that, that's undefined, and cosecant is reciprocal -1. And plot the point, and there's the angle. We want the x, y, and r, so x, y, and the radius. The radius is -3 squared plus 4 squared equals r squared. So we get 5. The radius is 5. And sine is y over r, y over r. Cosine is x over r, x over r. Tangent y over x. Cotangent reciprocal, secant reciprocal, cosecant reciprocal. Alright, and so we're going to do the same thing. We just have to find out where that angle is, find the x, y, and r, and then evaluate. So 180 degrees, we're going to go right there, and let's just let r equal 1 because that's easier. We could let r equal anything, and whatever the radius is, that tells us what the points will be. The x is -1 and the y is 0. We need secant, which is r over x, r over x. And here we're dealing in pi over 2 half pies, so we can just start with this. We know that's 0 pi, pi over 2, 3 pi over 2, 1, 2, 3. We know we're here, so we can just choose a radius of 1, and that'll tell us the x and the y. The x is 0 and the y is -1. So this is y over r, and that's going to be y over r. Pi over 2, we know pi over 2 is right there. R is 1. If the radius is 1, x is 0, and y is 1. So we know that y is 1, and we didn't move horizontally, so the x is 0. And cosine is x over r, x over r. Alright, pause and try those. If we don't know where 7 pi over 6 is, then we'll just count 1, 2, 3, 4, 5, 6, 7. We're going over there, and we could look at that triangle. It's a special triangle, 30, 60, 90. Remember that if that's the 30, we have a 1, 2 radical 3, so the 1, 2 radical 3. We have the short leg is a 1, the long leg is a radical 3, and that tells us that the x is negative radical 3 and the y is negative 1 and the radius is 2. That's y over x. So we found the y is negative 1 and the x is negative radical 3. So that's positive. We're going to multiply top and bottom by radical 3 and we'll end up with that. So let's go over that process one more time. We know we're dealing with 30-degree angles because it's 7 pi over 6, 1, 2, 3, 4, 5, 6, 7. But we need to know the x and the y, and we know it's a 30-degree reference angle. So if we drew a 30-degree angle, from memory we have to know that this is a 1, 2 radical 3. Then when we put these lengths over here for the coordinate, we know we went left for the radical 3, left would give us a negative, down gives us a negative. So we found the x, the y, and we see that the radius is 2. We can also do that using the unit circle, but we're not going to do it that way. 45s, so let's draw the 45s. We're going negative 45, so that's right there. If we memorize the 45-45 triangle, we know it's a 1, 1 radical 2. So in this case, this is positive 1, this is negative 1 for the x and the y, and then we'll call that radical 2 for the radius. Cosine is x over r, x is 1, and r is radical 2. So we get radical 2 over 2. 150 is a multiple of 30. 30, 60, 90, 120, 150. So that's where we want to look at the triangle. And if that's a 30, then we go 1, 2, radical 3. And for the coordinates, we're going to have a negative x value and a positive y value with a radius of 2. And we're doing secant. Secant is r over x, so the radius is 2, and the x is negative radical 3, 2 over negative radical 3, which would be rewritten as negative 2 radical 3 over 3. And let's just do one more. Pause and try that. .300 is a multiple of 30. And if we count around, we'd need 10 30s. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That means there would be 2 30s left over for the reference angle of 60. And then if we look at a 30-60 triangle, there's the 30 and there's the 60, we know that it's a 1, 2, radical 3. So we know that the point is going to have the x is positive 1 and the y is negative radical 3 with a radius of 2. And for sine, we want y over r, so the y value over the radius. And that's it for today.